we're going to take a look at SSH and creating server certificates for your known hosts file. Hello and a really big warm welcome to the command line of my Rocky 8 system. When I run the hostnamectl command, you can see in fact that I'm running Rocky Linux 8.10 and I've got two systems that are set up in the same way. But we're looking at the SSH Certificate Authority, so it should be fairly irrelevant, the distribution that you're using. I'm just going to gain some administrative privileges here, so sudo -i to open up an interactive shell. And I'm just going to edit my host file just to make it easy to access the two hosts that I am using. Both are Rocky Linux hosts, so we've got 192.168.56.101, which is this host, Rocky1, and I'm just going to put the domain example.com, and we can copy this line and paste it back in, and we can go to the 102 IP address, which is going to be rocky2.example.com. So this is just my fundamental plumbing, nothing really to do with our certificate authority, but just getting communication okay. And now when I look at pinging rocky1.example.com, yeah, we're getting a great response coming back from that virtual machine. And then rocky2.example.com, we're getting an equally good ping response coming back. So this is our basic plumbing that has been set up. We're now going to look at generating a certificate authority for our SSH server and clients. And it's set up in exactly the same way. SSH keygen, -f the file path. And here I'm putting in a shared directory, so it's going to be available to both of my Rocky hosts. And I'm just calling /vagrant/CA key, and then the passphrase. And obviously I'm just using a really easy passphrase here. We're not recommending that for your own environment. As we list out the Vagrant directory with a long listing, looking for CA and star, you can see then that we've got the CA key private file and the CA key .public file. And we can see that the permissions show as read-write just for the user, for the private key, and readable by everyone when we look at the public key, which is as you would expect. Now, for convenience, I'm using the shared Vagrant directory, which is available on both of my hosts. In your own environment, you might not have this, but you can easily copy the files from one server to the other so that they're available on both Rocky1 and Rocky2. Let's go ahead and move into our /etc/SSH directory. We're still working as our root user, and we can run the pwd command so we can check that we are where we're expecting to be. And then I can go through and run the keygen command again, but this time I'm going to use the option -s. So this is signing. I'm going to sign with the private key, so /vagrant/CA-key. The uppercase I for the identity, which we're just calling Rocky1. It is a host key that we are creating, so -h, and -n for the name of the host, and then rocky1.example.com. As we continue, we can use the uppercase V for the validity period, how long the key is valid for, and we're going to set it up for a year, so plus 52 weeks. And then, of course, we need to go through and sign our existing key. So with this, we can go through and put our SSH _host _RSA _ and key .pub. The passphrase is a passphrase that you saw me enter before. So this is the passphrase for the private key of the certificate authority. But we have now just signed the public key from our server with the private key of our certificate authority. We can go into our SSHD configuration file and we can add in a new configuration. I'm just going to add it in towards the bottom of the file. And the configuration that we want to add is then our host certificate and then the path through to the signed public key. So /etc /SSH, and then it's going to be SSH _ host _ RSA _ key -cert .pub. So just be careful with the underscores and the dashes there, making sure that we've got that right. But we can then go through and save the change. And of course, we can go through and check those files. When I look at then the public keys that I have here, we've just referenced the cert.pub. So SSH host _ RSA key -cert.pub. And we can restart our SSH daemon. Now, for our clients to be able to trust those server keys, we've got to make sure that the signing authority's public key, so if we cat out vagrant and ca-key.pub, is available to all of our clients. So I can then go through and append it to the etc SSH and SSH _ known hosts file. But it needs to be told that it is a signing authority. So once I've added the key through to the file, I just need to add in a certificate authority and a domain that it's working for. So I can add in @cert authority. So just in front of the key, we put in the cert authority, and we can specify that it's for all hosts within the example.com domain. So the etc SSH _ known host file accepts as a known host file for all clients on that system. We're trusting then the signing authority's public key, so any server's key that has been signed by that is going to be automatically trusted. So I don't have to worry about adding in the Rocky1 key or the Rocky2 key to my known hosts. We can then just make sure that we're using the SSH known host file. I'm just going to copy that through to the Vagrant directory to make that shared for the remote system as well. And now I can exit out of my Sudo session back to my ordinary Vagrant account. And as I SSH through to rocky1.example.com, you can see I'm being prompted for the password. I'm not being prompted to accept the public key. So this is good to go as far as the Rocky1 host is concerned. But of course, we need to add this configuration through to the Rocky2 host as well, so we wouldn't have to pick up the public key of the Rocky2 host. So if I exit out of my Rocky1 system, I can then connect into my Rocky2 system. With this system up and running, then we can really run through the same process. But we've already generated the CA key, so we're good to go with that. So I'm just gaining administrative privileges and moving back into the etc and SSH directory. And I'm going to then copy the Vagrant and SSH known host file through to here. This is really just trusting clients on this system. But the main thing as we then go through and take a look at our files is we've got the configuration files that we need, but we need to go through and sign with the CA the public key of this server. So SSH keygen -s as we did before, pointing through to the private key of our certificate authority, so /vagrant, and then our CA-key. We're signing it this time for the identity of Rocky2. It is our host key that we are creating. with the name of rocky2.example.com. And let's go back and just correctly spell Rocky2. And we're going to put that same validity period of 52 weeks. And then, of course, taking the public key of the server, so SSH_host_RSA_key.pub. So we're signing the public key of the server with the private key of our certificate authority, just in the same way as we did before. We're being prompted for the passphrase again, the passphrase of our CA private key. Now, having generated that signed public key, we need to add it to our SSHD_config. But rather than edit it directly, we can go through and just paste that information in. So host certificate and the path through to our recently generated signed public key and append it to the SSHD config. So this is the same configuration that we made before, but we're just using the simple echo command rather than editing the file directly. But make sure you are appending and then restart your SSH daemon. And that's all the configuration that is required to get the host keys set up on Rocky2. So we can revert back now to go back onto my Rocky1 system. And we're going to find now that the host key is automatically accepted on my Rocky1 client, that I'm just being prompted now for the passwords. So our certificate authority so far has been great for accepting a single public key that could be used for your whole entire estate. So your clients just need to trust that one key, and it's going to give them access to all of your servers that have been signed with that certificate authority. What we'll look at now is the same, but for users. Having generated our certificate authority, we can now generate user certificates using that authority. In generating our user certificates, if our users need to log on to a bunch of servers, well, we don't need to have the user's public key on every server. We just need to have the signed public key from our certificate authority. So we're going to begin now working as my Vagrant user, and I'm just generating a simple public key and private key pair for my Vagrant user. And I'm just going to call it, in this case, I'm just calling it user key. And I'm going to set up an empty passphrase so I don't have to worry about authenticating to my key. That is your choice as to how you manage that. So now we can go through and run our SSH keygen again, this time with elevated privileges. And we are going to sign the user's key, the public key that we've just created. So -S, as we've seen before, for signing, and going out to our private key from the CA, the identity, and here I'm just going to go through and put vagrant@example.com. So that's issued to the Vagrant user on this system. The -N is the user principal. This is then who they are allowed to log on as on the receiving system, so the remote user. Now, if I only want Vagrant to log on as the Vagrant user, I only put Vagrant in. But if I need Vagrant to log on as the Alice account or the Bob account, I can go through and put a comma-separated list of user principals underneath the option -N. So -N represents the remote user, the -I represents the local user. With those two options differentiated against, we can continue and we can add in the same type of validity period. Obviously, you can choose the validity period that you want, but I'm going to put in the uppercase V and 52 weeks again. And we are signing the public key of the user. Oops, I've just noticed that we've misspelled I've misspelled sudo, Control and E just moves me straight back to the end of the line, and we can put then the path through to our home directory, Vagrant, the .ssh, and of course we need to sign the public key that we just generated. So user-key.pub. Hit the big enter key, and of course we've got to authenticate to our CA's private key, so adding in the passphrase to the private key. So that's the user key that is created. So that's our first step. You could argue it's our second step, as we've already created the CA, but we're using the same CA as we created with our server. When using our SSH client, we need to make sure that we reference the correct signed public key. So we can do that through our home directory and the .ssh config file and creating our own host entries inside of this. With the file open, we can go through and create a new host entry. So we can give the alias of Rocky1 for us to be able to access this host. And of course, then we can put our host name, which is going to be then the entry that we have in our host file, or it could just be the IP address. So I'm putting here rocky1.example.com, but equally I could just put the IP address. We can now add in the username. This is a username that we want to log on the remote system, so this matches our user principal that we put in. We can go through and put the identity file. So this references the private key of the user. So we're putting the path through to the home directory, the .ssh subdirectory, and then the private key that we use to generate the public key. So user key, and then the certificate file. The certificate file is the trust relationship that is going to be set up because that is signed by our CA. Our servers are going to trust the CA. The trust relationship then will be for any certificate file signed by our CA. So we can go through and add in the user key cert.pub. And that's all the editing done for my config file. Now, if I move into that .ssh directory, it will make it easy for me to list those files. Running the ls-l, of course, we can see the permissions. And just take a look at the permissions on the config file. This is a file that we have just created. And of course, it's using the default permissions. But SSH won't work with these default permissions. The file has to be private to our user account. So I'm just going to use chmod and 600 to give it read and write to the user, but no permissions for anybody else. Now you'll be pleased to know that that is all of the user configuration done. We've generated the public key and private key pair, and we've signed the public key of the user with the private key of the certificate authority. But the server has to trust the certificate authority. So I can gain administrative rights again using sudo -i, and I can move into the server's SSH directory, so etc and SSH. And from here, I'm just going to copy the vagrant and ca key.pub file, the signing authority's public key, into the SSH directory. It won't work with the wrong ownership. So this way, then it's going to be owned correctly by the root user inside of the SSH directory. We can set up the trust relationship now by putting in the entry trusted user CA keys and point through to our /etc /SSH and /CA keys.pub file. So the public key that we've just copied from the vagrant directory. Remember, I just had that because it was shared between my two files. And we can then redirect that through to the sshd_config. So we've changed the server's configuration file, so we need to restart our SSH daemon. And with the SSH daemon up and running now, we should be good to go. the user's public key is going to be trusted on the server because it is signed by a certificate authority. I've just grabbed that into my paste buffer because I can use that on my second server later. But returning to my Vagrant user, I can now SSH to Rocky1, and we can see then with Rocky1, we can get directly in now. We don't have to accept the server's public key, and we don't have to put our password in. So now I'm returning back to Rocky2. We don't need to worry with any key generation, but we do need to make sure we gain our root privileges and copy the Vagrant public key into our SSH directory, just so it's owned correctly, and put that entry into the SSHD configuration file, so the trusted user CA keys, and then restart our SSH daemon. So that's everything done on Rocky 2, so we can exit back out and go back onto my Rocky 1 client system. Now, if I just try and SSH to Rocky 2, it's not going to work because we've put no host entry in for Rocky 2. So we must go back into my .ssh and config file. And I could put a default entry in my config file for all hosts, but I'm just going to put an entry in for Rocky 2 so I can copy these 5 lines and then I can paste them in below. And then it's going to be a matter of just changing Rocky 1 through to Rocky 2. And obviously we need to have that for the host name as well. The identity file and certificate file we're using is going to be exactly the same. But now I can get to Rocky 2 without having to put a password in. So again, you can imagine our whole estate of servers, how much time we can save by not having to trust every server on every client, but also from a server point of view, not having to trust every user in the authorized keys file. Working through this demonstration, we have set up an SSH CA. We've used the host certificate and trusted user CA keys value within our SSHD configuration, and we've signed our keys with SSH keygen -s, as well as creating our own config entries.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.